Okay, today I'm gonna be doing chapter 11 examination, so question number 1. So let's go ahead and see what the question says. It says that we have an uniform plank of 8 meters in length with a mass of 55 kilograms at 2 points located at 1 and 5 meters from the left hand end. What is the maximum additional mass you could place on the right hand of the plank and have the plank still be at rest? So for this, let me write a little diagram so we can understand this better. So it looks like we have 2. We have one here. Let me make another one here. This is going to be B. So it's saying that from the left hand we have this. So let me go ahead and make this right here like a little string. So we have 5 meters from this side, and then we have 3 meters from the other side. And then it says that we have a uniform plank, and let's see, the mass, it's gonna be 55 kilograms. And then the length of the whole thing, this whole thing, it's gonna be 8. So let me put it right here. Length, it's gonna be 8 meters. So let me go ahead and plug in what we have so far. Okay, so it's supported by 2 parts. It's gonna be, and we also have here this mass and gravity. So if we plug in our numbers into our equation, we can solve for mass, which is gonna give us the maximum mass that we need. So let me go ahead and do that, and let me get the maximum mass on the side. So this, we get that we're gonna divide 55, which is what it weighs, kilograms, times 3, which is gonna be this side. And then that's gonna give us, when we put in the calculator, 18.33 kilograms. Okay, let's see what part B is asking us. We're going to use a different question for part B. Part B is saying a bowling ball has a mass of 4.8 and a diameter of 0.216. A baseball has a mass of 0.145 kilograms. If you connect these two with a lightweight rod, what must be the distance between the center and the center of the baseball so that the system will balance the point where the rod touches? So let's see what we have first. Let me write the mass down first for the first one. The first is going to be 4.8 kilograms. The mass of the baseball one was 0.145 kilograms. And the diameter of this is going to be 0.216 meters. So what formula can we use this is that to find the radius we can use the formula right here. We can use this formula. It's gonna be diameter, it's gonna divide by 2. So let's see, we have our diameter, we can plug that in. It's gonna be 16 meters, 0.216 meters over 2. This is gonna give us that the radius, it's gonna be 0.108 meters. And this is gonna be the radius. So now let's go ahead and use this different formula, which is gonna be the mass of the first one, the radius, equals 0. And let's go ahead and plug in. We have most of the things that they're asking us for. We have the radius for it, minus the mass of this one, times this, which is going to be the difference that we need to keep it stable. This is what they're asking us for. So let me go ahead and write that down. Okay, let me multiply this together in our calculator. We get 0.44064 minus, we still have this, but times k, and then here we have 0.1566. This is gonna give us that we're gonna add them together, these two, and then we are gonna get 0.4563. So we need to get this by itself, which is what they're asking us, which is the distance of the rod. So let me go ahead and multiply it, and then we're gonna get that. The distance of those two, it's gonna be 3.147 meters. So this is the distance. I will keep the two of them stable. Okay. Now let me go ahead and go to part C. Let's see what it says. Part C. Okay. 3 small objects are arranged along a uniform rod of mass m and length L, one of mass m at the left end, at one of the mass at the right end is 2m. How far to the left-right should you place a support so that the rod with it attached will balance there? Okay. So we're gonna use the anti-clockwise torque formula. So the formula, it's gonna be rise the torque. And let me go ahead and put it right here. So we have this. Mass times gravity, 1.5 times x plus mass times gravity x plus mass times gravity. It's going to be equals to m L2 minus x. And now let's just plug it in what we have. And let's simplify it. This just converts to x to plus x equals L minus 2x, because we break this down. And down here we have L over 2 plus 3x, because we added all this together, equals L minus 2x. And then we have and then right here we're gonna put 5x, which is what this gives us. When we move this to the side, it's gonna be L2, and then we try to get the x by itself, and then we notice that we get we get L over 10, which is gonna be how many centimeters we have to go left and right to place the support. Okay, now let's go ahead with part D. Part D. Let's see what they're asking us for part D. A small airplane with full tanks but now occupants or baggage has a mass of 1.7. They give us a center of gravity that is 2.58. So let me write that down. We have the mass. It's gonna be 1.117 times 10.3 kilograms. Then we have the center of gravity for the first one. And then we also have another center of gravity, the mass of the pilot. So let me put that down. This is the center of gravity. Then we have the mass of the pilot, which is going to be 75 kilograms. Then we have the pilot seat is behind the nose. So we have another center of gravity. It's going to be 2.67 meters. And the baggage compartment is they're giving us another one here, which is the baggage one. Let me write it down. This one's going to be 4.3. And let's see what they're asking us. What is the maximum mass that the baggage compartment can hold? So let me go ahead and use the formula to find this. We're going to use the following formula. We're going to use this one that we previously used. M1 times X1 plus M2 times X2 plus M3 times 3X3 over M1 plus M2 plus M3. So well, let's go ahead and get that. We know that we already have most of the digits in here. So let's go ahead. We have the mass of the first one. Then we have the center of gravity. Then the mass times center of gravity. And then we don't have the mass of the baggage compartment. So that's what we're finding right here. But we do have the center of gravity over the masses of every single one. Plus 75, and we still don't have this one. Okay, now I'm gonna go ahead and continue over here. So when we have this, we know that we have to simplify. So let me go ahead and simplify. Just to multiply, we get 0.05 this plus 86 M3, and then at the bottom we still have 2,245 plus M3, because it's what we're trying to find, equal the center of gravity, which we already have from the start. When we look at this, we know that the only thing that we can do is find the lowest common denominator. So let's go ahead and find out the LCD. So when we go ahead and do that, we are gonna put it right here in our calculator. And when I go ahead and do that, we get this too, and then 43 M3 over 10. And then in this side we get 3436.2 plus 2.76 M3. Then when we simplify for M3, which is what we want to find, we get that it's going to be 145.14 kilograms.